Hey guys, in this video we're going to be talking about percent composition by mass. And what we can do actually is take this term and break it down into pieces to determine exactly what we're solving for. So remember that a percent is actually just a ratio of two numbers, and a composition is the makeup of something or the pieces of something that make up its whole. So when we're talking about percent composition by mass, what we're really determining is what impact an atom's weight has as comparison to the total molecular weight of the compound. Now let's recall that molar mass of a compound is the summation of all of the atoms added together, which is determined by its molecular formula. What we can also do is that we can say the molecular mass of an atom itself is the summation of its protons and its neutrons. So when we're looking at percent composition, you'll find something in a question that says you want the percent composition of some atom in some compound. Okay. Now, that is actually asking you to find the ratio of one atom's weight to the comparison of the whole molecular compound weight. So that's actually how you derive your formula. You're going to take the number of atoms that you have total of your specific atom that you're deciding its percent composition, multiplying it by its molecular weight, which again is determined by the summation of protons and neutrons, and you can find it on your periodic table. Then you're going to divide that whole thing by the molecular weight of the compound itself. So let's look at our first example of CO2 gas. Now, CO2 gas, again, is the gas that you exhale when you breathe, as well as the byproduct of cellular respiration when you break down glucose and with oxygen in order to form ATP and energy. So when you first do your percent composition by mass, one of the good things to take an inventory of is all of your elements in your compound. So we can make a little chart on the side, and it just helps you keep things in order. Now remember that if there is no number as a subscript for an atom, you can assume it is 1. Okay? You don't have to do that, but again, it keeps housekeeping things very clean. So we have one carbon atom here, and we have 2 oxygen atoms here. So what we're going to do is we're going to say, let's find the percent composition of oxygen. And in order to do this, what we'll do is we'll take the number of atoms of oxygen, which is 2, and we'll multiply that by the molecular weight of oxygen, which is oxygen's protons and neutrons, and that comes to 15.99. I do not round. I like to keep my numbers pretty consistent, so that's why I'm not going to 16 on that one. Also guys, remember, it is very, very important. Keep your units. They come in handy because you can see exactly what cancels out. And with percent composition, everything's going to cancel. So we have grams per mole here. It's not just grams. Keep that in mind. And then what we're going to do is calculate the molecular weight of the entire compound. So again, we can take one carbon atom, multiply it by its molar mass, which is 12.01 grams per mole, add 2 O atoms times 15.99 grams per mole. Okay, and when you do this, you're going to get 2 times 15.99, which is 31.98 grams per mole, all over 1 times 12.01 plus 2 times 15.99, which is 43.99 grams per mole. Now this is why I was mentioning how it's very beneficial to always keep your units. Notice how these two units cancel. That is a very good way of determining that we're on the right track, because what's going to happen is we're going to get a decimal here of 0.7269. Now remember, very important, this is a percent. This is a ratio of two numbers. In order to calculate the percent, we have to multiply it by 100%. A percent is a unit, so we have to multiply by 100%, and we get 72.69% oxygen to CO2. Okay, so let's look at another example. So let's look at this example. Let's look at calcium carbonate. Now again, calcium carbonate is your friends and mine, chalk. Again, there's no rule that says if there's no subscript, we cannot go ahead and assume it as 1. So let's go ahead and take an inventory again. So we have 1 calcium atom, 1 carbon atom, and 3 oxygen atoms. Now let's say, for example, I wanted to find the percent of carbon in this molecule. So again, going at our formula, we have 1 carbon atom times 12.01 grams per mole. Remember, keep your units, guys. All over the molecular weight of calcium carbonate. So you're going to have 1 calcium atom times its molar mass, which is, I wore my handy dandy shirt today, 40.08. I did wear that shirt just for the purpose if I did forget molar masses of elements. We have plus 1 C atom times 12.01. And again, guys, keep your units. Kind of being bad about that right now. Alright. Plus 3 O atoms times 15.99 grams per mole. Okay, so we'll have 1 times 12.01, which is 12.01, and you have C atoms per grams per mole. Oh, 2 grams per mole. All over the molecular weight of calcium carbonate, which is 100.05 grams per mole. Sloppy. Okay, so now that we have this, we can take the quotient of 12.01 divided by 100.05, and we get 0.119. Now remember, again, this is a quotient, so it's very important to keep and multiply by 100%, which will give you 11.9%, which is your answer. In our next video, we'll do some more examples of these.